Assalamualaikum and welcome everyone. Today we are diving into the foundational concepts of algorithms and C programming. Before we look at the code, let's talk about the C programming language itself. So C programming or C language is a general purpose, block structured, procedural, case-sensitive and highly portable high-level programming language. So the language was developed by Dennis Ritchie, a person named Dennis Ritchie at Bell Telephone Lab back in 1972. Now you might be wondering, why are we learning a language from the year 1972? Well, the reality is that C language has only matured over time. The C language is so powerful that entire operating systems like Unix, UNIX, are coded in it. So it remains a prerequisite in almost any software industry today. So these are the overview of topics that will be covered in the lecture on Introduction to Algorithm and C Programming. So based on these slides, it outlines the core areas students will learn, that you will learn. These include C program structure and data types. So this subtopic is actually requires to understand how C programs are organized and how different kinds of data are represented, followed by input and output statements. This is the topic or subtopic that you will learn on how programs receive data from users and display results. The third one is the basic operators. This will cover arithmetic and other fundamental operators used in C. Then we have logic and comparison. This will introduce decision making using logical and relational operators. And finally, programming errors. This part, we will learn how to identify common types of errors that occur during coding and execution. So for this part, part 1, we will take a look further in C program structures. Now, as a quick recap from our previous discussions on algorithms, remember that before we write C code, we must understand our logic. The right way to do this is by mapping out our algorithms using pseudocode and flowcharts. For example, if we want to display a simple message like "Hello World," our pseudocode simply begins, prints the message, in this case "Hello World," and ends. While a flowchart represents this exact same logic, but visually with the begin placed in an oval shape, a print of "Hello World," in parallelogram and a back oval shape again for closing N. So always remember, the best way is to plan your logic before you type your code. So on this slide, we are looking at example 2, where the task is very simple. The task is for us to write a C program that displays the message "Welcome to C" on the screen. So first, before we jump straight into the code, notice that we are still following the same logical structure as before. The algorithm is very straightforward. So you'll start first with begin, print "Welcome to C," and end. This simple logic is represented using a flowchart, which visually shows the program starting, printing the message, and then ending. This reinforces an important habit in programming, that you need to always think about the logic first, then you can write the code. So this shows the simple C program code based on the logic that you draw or make through the flowchart. Now let's look at the actual C program shown on this slide. So you get the first line is, the third line. You have hashtag include a bracket here, stdio.h. So this stdio.h represent the standard input-output file extension. So this hashtag include standard input-output file extension is called a preprocessor directive. It tells the compiler to include the standard input-output library. We need this library because it contains the printf function here, which allows us to display whatever we want to display, in this case the text of "Welcome to C" on the screen. Next we have int main void. This is the main function, and it is the starting point of every C program. When the program runs, execution always begins here. The curly braces here and here that follow after the main function define the body of the main function. Everything inside these braces, this is what the program will execute. Inside the function, we see this statement, printf "Welcome to C." So this line instructs the computer to print the message "Welcome to C" on the screen. So notice that the text is enclosed in double quotation marks, "Welcome to C" /n close with the double quotation mark on the screen. So this is required when printing a string. After that, we have return 0. So this return 0 statement indicates that the program has finished executing successfully. Returning 0 tells the operating system that there were no errors during execution. Finally, the closing brace. So the closing brace marks the end of the main function and the end of the program. So in short, or to the key takeaways for this part is that we already been introduced how to convert a simple algorithm into a C program. Then we learn also the basic structure of a C program. We use printf to display the output, and we saw how the main function and return 0 control program execution. So this example may look very simple, but it actually introduces the foundation of all C programs. So as we move forward, we will keep building on this structure by adding variables, input, calculations, and decision-making logic. Now program comments. Comments are non-executable tags. Comments are ignored by the compiler, meaning they do not affect how the program runs. The purpose of the comments is purely explanatory. There are two types of comments in C programming. The first one is block comments here, which start with /* and end with */. So this is block comments, while we also have single line comments, which start with a double slash, and each new line must begin with double slash if the comment spans multiple lines. So why we need the comments? The comments improve readability and maintainability. In simple words, these comments help programmers and others understand what the code does, making programs easier to read, debug, and maintain. Comments cannot be nested, meaning you cannot place one block comment inside another block comment. For example, you have the /* here with some comments, please, and put another comment inside the first comment. So this will become invalid and will cause errors. The best practice in programming is to use comments to explain why code is written a certain way, not just what the code does, especially for complex logic. Preprocessor directive. Preprocessors run before compilation. They process the source code before the compiler translates it into machine code. The hashtag include stdio.h, the standard input-output file extension, is essential for input and output. So this header file provides functions like printf and scanf used for displaying output and reading input. So later on, we will take a look further detail about this printf and scanf. C program translation happens in stages. So the source code written by programmers is first stored in a file, meaning they need to have source file. So for example, let's name the source file. We put a name program. So your source file will become program.c. So it is saved in the name of program.c. So this file is then processed by preprocessors and an expanded source code file is generated named program.i. So the file must be in the form of .i format after being preprocessed from the source file. So this expanded file is compiled by the compiler and an object code or an object code file is generated, and then we can name it, or it will become program.obj. Okay, sorry, I forgot to put the format for the object file. So you need, let's say you have the program name again, and it must be saved in the .obj format. Okay, that's for the object file, object code file. And finally, the linker links this object code file to the object code of the library function to generate the executable file with the format of .exe. Exe stands for execute, right? So which is why it will finally save in a file in a .exe format. So basically, this slide explains that the preprocessor directives prepare the program for compilation, and the hashtag include stdio.h is required to use standard input and output functions in C. So again, A preprocessor directive is an instruction given to the preprocessor before the actual compilation starts. So you have standard library header files provide built-in functions that programmers can use, such as this one, stdio.h. This is for standard input and output. And then you have math.h. So this is specific for mathematical functions. So examples of commonly used header files like stdioh is used for input or output operations like printf and scanf. For stdlib.h or standard library file extension, it is used for number conversion, memory allocation, and random numbers. Now for string.h. So string.h is used for string processing, meaning handling text as sequences of characters. In C programming, text is treated as strings, meaning sequences of characters rather than words or sentences. This is because the computer does not know anything about words or concepts. If you have string, anything comprised of characters, you can have string anything comprised of characters or even characters plus numbers. The main function serves as the starting point for program execution. So it is placed here before the opening bracket. So the main function usually controls program execution by directing the calls to other functions in the program. So every C program contains one or more functions, but exactly one must be main, which is mandatory. The main function is the entry point of a C program, meaning program execution always starts from main function. The braces, this one, the opening and the close bracket braces, define a block of code in C. All function bodies, including main function, must be enclosed within these braces. At the very minimum, a valid C program must include first line main function, and then after the main function you start to put the opening braces, and then you close back after you put the statements. So this actually shows the basic structure required for program execution. So this emphasizes that the main function is compulsory in every C program, and the main function serves as the starting point of execution, and these braces are used to group program statements into blocks. That is the idea. Now printf. Printf is used to display output on the screen. It is a library function that sends formatted output. It can be text or values to the display. The stdio.h must be included to use the printf function. The printf function is defined in the stdio.h header file, which must be included using #include bracket stdio.h. As you can see, the text printed by printf must be inside the double quotes. So you have a strings like this, welcome to C '/n are enclosed in double quotation marks. The word printf itself supports the formatted output. The F letter in the printf word represent format. So it can print both text and variables using format specifiers. It can print both text and variables using format specifiers, making it useful for displaying results clearly. The printf function and scanf are standard input or output functions. They are both built-in functions used for formatted output, printf, and formatted input, scanf. So this example shows you only the printf for the output, but not the scanf for the input. But that's the idea. So this printf is a fundamental C function for displaying output, and it requires the stdio.h header file to work correctly. The printf function statement. So just now we said that printf function is used to display output. It instructs the computer to print text, or we call strings, inside double quotation marks to the screen. Each printf line is a statement, and every statement in C must end with a semicolon. So the escape sequence with the notation of /n is used to move the cursor to a new line after printing text. So the printf can also print variables and special characters, not just plain text. So in short, this slide explains how the printf function works, the importance of quotation marks and semicolons, and how escape sequence, the /n, creates a new line in output. So you can take a look at this table here. The variety of escape sequences, it can be written as /n here, new line. The effect, it will be new line. So if you put /t, the effect will be in a form of tab, and different escape sequence will give different kind of effect. That's the idea. And now return 0. In C, return 0 is used to exit a function. It ends the execution of the main function and sends a value back to the operating system. Return 0 indicates successful program execution. A return value of 0 tells the operating system that the program ran without errors. Commonly used in main function. In C programs, return 0 is standard practice at the end of main function to signal normal termination. So it basically marks the end of the program. So once return 0 is executed, the program stops running. So this return 0, although it's looks not important, is actually making an important part of the basic C program structure, because return 0 ends the program and indicates successful execution. So return 0 indicates that the code has been implemented effectively and normally has accomplished its objective. If there's a case a return 0 is not displayed, instead of return 0 it shows return 1, it indicates that there would be an error in the program's implementation, meaning it is not operating as planned. Multiple printf statements and new lines. Printf function continues printing from where the previous statement ended. So if no new line, the /n is used, the output will continue on the same line. Multiple print function statements can be used together. How? By splitting a sentence across several printf statements, and they will appear as one continuous line unless a new line is added. So the new line should be placed carefully using /n at the end of a line is better programming practice than placing it in the middle of a string. So incorrect string splitting causes errors. Writing a string across multiple lines inside a single printf without proper syntax is wrong and will definitely cause compilation errors. So the good output formatting improves readability. The proper use of print function and the escape sequence, the /n, meaning the effect of the new line, ensures clear, well-formatted program output. So it's basically shows you how multiple print function statements work together and why new line placement matters, and it also highlights the correct versus incorrect ways of printing text in C programming. Okay, for example, printf starts printing from where the statement ended, so the text is printed on one line. So you can see here it's separate. Welcome to C string or statement to two printf function. The first one welcome and followed by the 2C. Okay, and they will still printed on one line. So let's say you have the different kind of arrangement. In this case, printf, first line is the printf welcome, and you put the 2C escape sequence in the next line. It will give a incorrect ways of printing text. So you have to properly put the placement of the new lines in print function. Sorry. So the new line character or at the escape sequence, the /n moves the cursor to a new line. So it controls where the next output will appear on the screen. New lines can be placed inside a string, so like this. But it can be hard to see and understand, making the code less readable. So this is not recommended. For the better programming practice, it is more clearer and easier to maintain code when new lines are placed at the end of print function statements. Okay, like this one, not in the middle like this one. So as you can see here in the black text box here, this is the alternative approach showing you using multiple print function statements, which each of them ending with new lines, the /n, that gives cleaner and more readable output. So while the /n controls the line breaks, the clear placement of new lines improves readability. And using multiple printf statements is often a better and safer coding practice. Right. Writing and running programs using code blocks. Now that we understand the basic structure of a C program, let's talk about how we actually write and run our programs. So for this course, we will using an open source IDE platform called Code Blocks. Sorry, this is with the S. So an IDE here stands for Integrated Development Environment. So the IDE code blocks help us write, compile, and run our C programs more easily. So after writing your C code in the C or in the code blocks, you can compile and execute the program by clicking the build and run button. Okay, so this button first checks your code for errors and then runs the program if there are no problems. Okay, so if your program is correct, the output here will be displayed on the screen. If there are errors, code blocks will show messages to help you identify and fix them. So remember, write your code in code blocks, click Build and Run, check for the output or error messages, and be done. So this is actually the basic workflow you will use throughout this course. When all of you get back from the Raya breaks, we will have a lab session starting on the 4th week, I think, okay, based on the teaching plan. So in the lab session, you will get things that you've learned in theoretical form more clearer when you do the practical practice during lab session. Okay, so this is how for this chapter, the first subtopic about how the structure of the programs looks like. Okay, so I hope all of you understand, and thank you for your time. We continue the next part, the data part, in the next lecture. Thank you and Assalamualaikum.